Good afternoon, everyone. Thank you very much for joining us today for this very first Cloud Native Meetup Romandie virtual. I want to thank you to participate tonight with us for this very first time. I will share my screen to show you a little bit what's in for you this afternoon. So first of all, we will ask you to make it a little bit more interactive with the audience, to join either slido.com or downloaded it on your cell phone. And make sure to add the number 56162, which is for the Cloud Native Romandie this evening. So I'll leave you a couple seconds like this that let us know a little bit where you're from, and we'll share this on a screen. And also to let you know a little bit how we organize ourselves. So the presenters and the speakers and myself, we are in a Zoom session, and then we are doing live directly with thanks to the YouTube channel. So we have 30 seconds to 1 minute video in between speakers to ensure the smooth transitions. And after this, I will follow up, of course, on the YouTube channel to make sure that we take all the questions and we don't leave any unanswered questions. Whoops. So this evening, the introduction, and I wanted to thank you as well, and thank to our colleagues from Cloud Native Bern and Cloud Native Zurich, who helped us to know how we do the virtual sessions. And so tonight we will start with Bivac, presenting Bivac with Raphaël Pinson from Camptocamp. Then Pablo Mercado from Triggermesh, who will present us the Triggermesh solution, actually. Then we will have a 5-minute break, and then we'll start the third session with a question where you can answer and you can already think of to know which type of cloud native sessions or topics you would like us to present in the future. So you can already think of and put it on a paper, and after the 5-minute break, you can share it with us. And then we'll attack, last but not least, with Eric Sorenson from Puppet, presenting us the new innovative relay solution. And we will finish by 10-15 minutes of Q&A, and to make sure that we'll finish sharp at 7 p.m. to give your time with your family. Thank you very much, and I hand it over.
Thank you, Thierry, for this intro. Thanks, everyone, for joining us tonight. Let's see, Thierry, do you already have questions? Do you already have answers to the first survey on Slido?
Yes, I'm just sharing it as we speak. And of course, that's when we need it the most, that it's not working. Otherwise, that wouldn't be the right experience. There we go.
Well, it's going to be pretty exciting tonight. We have three subjects. I'm not going to say three great subjects because one is mine, so obviously I'm biased. But we have two exciting subjects on Triggermesh and one on Relay, which is a new product from Puppet. And as a big fan from Puppet myself, I'm excited to see what it will look like. So what do we have in Slido at the moment? Where are you joining us from? We have people from Châtel-Saint-Denis, from Bern, Canton, Königs, from Meyrin, Échallens, Lausanne, Vevey. Pretty cool. Keep it coming. Great. So there'll be other surveys during this this session tonight. Zurich even, pretty cool. We have people from all the way in Zurich. This is a global event. Shall we get started with the first talk then? Let's go ahead. I'll just steal the screen and get started with the talk on Bivac. See you on the other side. Right. So My name is Raphaël Pinson, as Thierry already presented me before. I'm an infrastructure developer working at Camptocamp for the last 8 years. I'm also a trainer. I like to share everything I learn and to make people benefit from the stuff, from the mistakes I make and all the things I learn every day. I'm a DevOps practitioner and I'm specialized in Puppet, OGS, Terraform, and Kubernetes. And obviously today I'm going to be focusing more on the container side as I'm talking about Bivac. Just give me a moment here. Uh, there we go. So containers. We're in 2020. The big container thing started about 5 years ago. A little bit more if you've been in development and you've used containers to do acceptance testing and all kinds of testing using containers, but really putting containers in production with Docker first and then with Kubernetes and all kinds of other orchestrators started really 5 years ago. And now there's containers absolutely everywhere. Every big company is equipping themselves with some kind of Kubernetes cluster, automating things using Kubernetes. So we have containers, that's a fact, and it's here to stay at least for a while. So what are the good practices when it comes to containers? Normally, we consider that containers should be stateless. So there's several ways of being stateless, obviously. One way is have no persistent data at all. So if your container, if your service can be entirely stateless, and whenever you request it, it actually doesn't require any data whatsoever, it just makes up data or doesn't need any data, that's the first way of doing it, which is the ideal situation. You can just scale that container however you want on a Kubernetes cluster and not care about where your data is located. When that's not possible, there's always the possibility of using a database, obviously, as we've been doing for years, actually. So store your data in a database outside of the cluster, and then your container is pretty much stateless because whenever it connects, whenever it comes up, it can connect to the database, get the data there. And you can scale your container as much as you want. You can put it on different nodes, move it from one node to another, and it will still find its data on the database. It won't be a problem. And finally, there's a special kind of database, let's say, which is object storage. We got used to it using S3, for example, or Ceph. And this is another way of getting rid of the data problem in containers, which is to store it using object storage and use some kind of API to access the objects you need. This is not always possible, however. And in reality, many containers still need local storage for lots of different reasons. Just because you put an application in a container doesn't mean that your application was made to be run in a container. So very often, a lot of applications need to access files on disk. They can't access files in object storage, and they're not made to work with a database. So the file needs to be on disk. It could be for performance reasons as well, because if your application has a local cache, for example, it might be much easier to store that cache on disk, where you can rely on a file system that is fast, rather than storing it outside of the cluster, where there will be some kind of network latency at some point. So when it comes to local storage, depending on how you're launching your containers, you'll have different options. In Docker, that's typically using a Docker volume, usually a local volume. In Kubernetes, you'll be using PVCs that will request physical volumes, so PVs. And in Rancher One, if you're still using Rancher One, I love Cattle, so I'm going to mention it. There was a Rancher volume plugin as well, which allowed to dynamically start volumes and associate them with nodes. In both Kubernetes and Rancher, this system, so Rancher One in this case, Cattle, these systems are made to provide volumes on the go dynamically to the containers whenever they need them. And there's different kinds of volumes. But then as soon as you have volumes that are available, there comes the problem of what do I do with this data? Obviously, this data is necessary for the application. So how do I back it up? So backing up data, there's different options. There's two approaches essentially. And most companies use the first approach, which is the infrastructure approach. It's not a problem of the developers to back up the data. It's a problem of the infrastructure to back up the data and be able to restore it. So in a lot of cases, whether in Kubernetes or in other systems, Companies rely on NFS systems or CFFS or some kind of network file system. And this network file system very often run on specific file systems themselves, such as ZFS, for example, which allows to have snapshots. And so very often you have the infrastructure team that will take care of snapshotting the data on a regular basis so that if ever the developers need to find their data again, it's been snapshot and it can be restored. This is more of a disaster recovery kind of approach usually. It doesn't allow the developers to easily access their data, and it doesn't allow them to manage their backups in an application uh, logic in a way. So the other way would be to back up from the application side. So it's an application backup. I know where is my data. I want to back it up, and it will be a per data location. This specific data needs to be backed up in this specific location, and I want to be able to restore it at some point. How do you back up? So traditionally, we have this problem in infrastructure that the backup location is unknown. Where is the data we need to back up? You come on a machine and you look at the data, and sometimes it's in /var, sometimes it's in /srv, sometimes in /opt, sometimes somewhere else entirely different. There's no way to know on a typical machine where the data is that needs to be backed up. So you need to talk to the developers and say, okay, where is your critical data, and hope that you find all the critical data. And then you need to make custom scripts usually that will find this data, that will prepare it properly, and then send it to be backed up. In containers, funnily enough, the problem is a bit more simple. The location is known, because if it was not known, if you didn't know where your critical data is, then you wouldn't be able to declare a volume for it. And if you don't declare a volume for it, then whenever you restart your container, whenever you scale your container, you recreate your container, this data is going to be lost. And you'll find out very quickly that your critical data is missing. So the critical data for the application is necessarily stored in a volume, and in a named volume, I would say, if you're in Docker. It won't be some kind of empty dir in Kubernetes. It needs to be a volume that you will be able to find again when you start your container a second time, when you upgrade your new version, when you scale and so on. You need to be able to find this volume again. So funnily enough, it's easy enough to find where the data to be backed up is stored. It's in a volume that was declared. So it's possible to automate. What's the idea? Is just let's look at all the volumes we have and see and start backing them up. And maybe we can have a blacklist afterwards that removes the volumes that don't need to be backed up, because maybe it's just cache that we want to have again when we scale or when we upgrade. We don't want to regenerate the cache, so we want to have it again, but it doesn't need to be backed up because it's okay to regenerate it in case of disaster recovery. So there will be exceptions, but most of the time, you actually want to back up named volumes. So that's the idea that was developed in Bivac, which is the tool we developed at Camptocamp. It's an open source backup tool for container volumes. It's been available for a few years, and it supports different backends, different orchestrators. The first orchestrator that we implemented, kind of obviously, because it was 2 or 3 years ago, we didn't have Kubernetes in production, was Docker itself. So with Docker, it will just connect to the Docker socket, list all the volumes, exclude the volumes that are not named, which are volumes that have names with 64 characters, and then starts backing them up. So essentially, we'll take these volumes, mount them, and send them somewhere on object storage. And then you can have Kubernetes. In Kubernetes, instead of using the local Docker socket and listing the volumes, it will list the PVCs using the Kubernetes API, and then mount them in a container and perform the backup. And then we had a plugin for Rancher as well. We still have Rancher 1 clusters running. So we have a plugin that supports Rancher volumes as well in Bivac in order to back them up properly. So how do you install Bivac? It's pretty simple. You can install it locally with Docker if you want to use it with the Docker socket. There's a sample in the GitHub repository that has a Docker compose.yaml. This is an excerpt from the Docker compose.yaml. So we just launch the Bivac image with the manager. So Bivac is made of 2 parts. There's a manager that runs in your cluster all the time, and will perform the backups themselves. And there's a client that can allow you to connect to the manager, list the backups that were made, perform a new backup, restore backups, and so on. So this manager has a port it can listen to when you want to use the client. Otherwise, if you just run the manager, it will just perform the backups and that's it. You can just let it run in its corner. If you're running it on the Docker socket, obviously it needs to access this Docker socket. So here we're mounting the Docker socket so that it can read from it. It's not going to write anything. It just needs to read from it. And then the environment where we need to pass the name of the agent image that will be used. And there's a PSK that can be passed to authenticate between the agent and the server. The RESTIC password, which will be used by RESTIC to connect to send the backups using RESTIC. So RESTIC is a backup solution that is used by Bivac to perform the backups. There's a target URL, which is where you want to store your backup eventually. So some kind of object storage that is supported by RESTIC. So this is actually path to RESTIC for the backup. And then some credentials that allow you to connect to it. So either AWS access keys, or it can be some other forms of keys if you're using another infrastructure as a service. If you want to install it on Kubernetes, we have a Helm chart that is ready. So I put that as simple as this. Actually, it's as simple as this, but you need obviously to provide a value file. So typical values, the YAML, with the types of answer that we have in the previous slide here, with the access key, the secret key, and so on. Typical use of Helm. If you've been using Helm in Kubernetes, it's a package that provides all the necessary Kubernetes objects to deploy the Bivac application with parameters allowing you to tune it to your needs. So what can you do with this if you download the client on the agent on your machine? You can connect to the Bivac manager and you can perform backups. This is what I'm doing here. Bivac backup SSH config. So this will take the SSH config backup, the volume that has this name in Bivac, and actually perform a backup. You can list the volumes that are known by Bivac. So Bivac names the volumes and you have the ID, the name, the host name that it was declared on, the man point on the host name, the last backup date, the last backup status. So that comes from RESTIC.
Sorry, Raphaël, to just interrupt just 1 second. We have a little issue apparently with the video where it's a little bit too pixelized. Is it possible to make it a little bit bigger for the audience to see? And I apologize to the audience who will share the presentation afterward.
This seems to be a problem with Zoom, probably. I don't think we cannot change the resolution. The max resolution in Zoom is 720.
Okay, just for the audience to see that we are following, and we will share with you the content afterward.
Sorry about that. So backups can be restored as well using the client. So Bivac restore will restore it. Will restore the backup. Bivac also exposes metrics, which can be used typically by Prometheus. So Prometheus is largely used in Kubernetes clusters to gather metrics and then send them typically to Grafana to generate graphs. So Bivac can do this. This is an excerpt again from the Docker Compose, from the documentation, where you can just add this job name to your Prometheus server to get the metrics from Bivac. So the target here is Bivac, which is the name of the container, in this case in Docker Compose, on port 8182. But obviously in a Kubernetes cluster, you can do it differently. You can have your own Prometheus server running in your project, in your namespace, and then go through a local service, for example, cluster IP service, to access Bivac, and then get these metrics and get them back up to your federated Prometheus to make some graphs. We typically use it at the moment with Alert Manager to make alerting. So this is how we use it. We have rules. So Alert Manager can be used in Prometheus to make alerts. And so these rules here, there's two rules. One is backup error, and it typically uses Prometheus metric here, Bivac backup exit code. And if there's one backup exit code that is greater than 0, that is not 0, then that triggers an alert. And then backup outdated is the current time minus the last backup should be less than 49 hours. So if there's more than 49 hours, if it hasn't run in 2 days plus 1 hour, which is the time it could take to perform the backup probably, then the backup is outdated and we get an alert from this. All right, I'm a little bit early to finish, but yeah, that's more time for questions. So are there any questions?
So I just had a question. Which backup engine does Bivac use? I don't know if I followed this one, if you already mentioned it, or if that's in addition, please.
Yes. Yeah, actually, yeah, it uses Restic. So previous versions of Bivac, which was called Complicity, used Restic and rclone, but actually there's no need for this anymore. Restic does pretty much everything we want. So Bivac currently uses Restic.
Okay, and the second question that I have is, can Bivac parallelize backups as well?
Yes, so backups can be parallelized. By default, it will run 2 backups in parallels, but you can change this value. It's a flag, it's a parameter that you can pass to Bivac to increase the amount of backups it does in parallel, which means that it actually just launches one container for each backup and mounts the volume in this container, so it can launch several containers in parallel to backup.
Okay, and we have a question from Mihai. What is the benefit of our CNCF Velero project?
That's a good question. I didn't start the Velero project. It actually came after Bivac, but because it's made by people that are better known, we didn't communicate as much. Velero was actually made to back up ETSD, a TCD. So it's more of a disaster recovery tool originally to back up the objects in Kubernetes, whereas Bivac was made with the idea of backing up the data from the containers. I know that Velero is actually evolving into this. I'm not sure it has exactly the same features. I wouldn't be able to tell, but it's just 2 products that were created separately with different goals originally.
Okay, thank you very much, Raphael. I don't think we have any more questions. We can just give a couple more seconds to the audience to see if any additional question is coming up. So I think not for the moment. So I think we can take a little mini break of 1 minute, and then we will follow up with Triggermesh with Pablo Mercado. Thank you.
Hi, everyone. Hope you can hear me.
Absolutely, we can.
Cool. So,
and we see better, so that's good. The definition came back. Thank you very much, Pablo.
Oh, awesome. So that's good news. I'm Pablo Mercado. I'm a software engineer at Triggermesh. I guess some of you already know Triggermesh, but I'm going to do a brief introduction. So Triggermesh was founded 2 years ago by Sebastian Wasgen, which I think is familiar for most of you, Mark Hinkle. So if we fast forward, we are like 10 to 15 employees and collaborators. What we do is we leverage on Kubernetes and also on Knative to offer a serverless experience that help controlling the ever-growing event ecosystem. So sometimes when people think of serverless, they think of functions. And yeah, functions are important, but at the end of the day, when you have a bunch of functions, you'll need to categorize them. But still, all those functions are posting messages. Those are events that get into your system. And there's so many of them that you need to have some way of having a registry of them and being able to reuse them. So that's like the day two of serverless. So we are building a product that is helping on the first stage, just the same as you could do with Lambdas or any other cloud provider or tool around, but we are very much focusing on the event side. So I don't have a presentation. I'm going to show you something that we built, which is called Bridges. But first, I think we can take a stroll through the UI. So
Pablo?
Yeah.
Just a minute. Can you maybe zoom a little bit? Apparently, it's a little bit small for people.
Okay.
If you can make it a little bit bigger.
Yeah, and probably I can share only that window. I think that should help. So hold on a sec. Should be better.
Yeah, that's definitely better.
Okay, so let me log out. So this is our product. This is the cloud that we've been building. You can log in with a range of different identity providers. So once you get in, you'll find here at the left a number of categories. I'll go from bottom to top to end up with bridges, which is what I want to show today. So as we mentioned, this is we have Kubernetes underneath. So everything you'll need to tell us about your credentials, they'll be put here into secrets. Some of them that we use or people use often, you'll find it with a pre-formatted way. But if you need to create some generic one, you have always this other here. So then we have this laboratory. The laboratories are some preview features where you can build your own functions from here, or maybe from a CLI that we have. And it's you get a serverless YAML file where you ask for a runtime, and then you get a function running. That's not something we are to demo today, but this is the classical, what you could expect from a function or a serverless standard product. So then here in Actions, what we are offering is an experience close to what GitHub Actions does. But this is generic, and you end up with your function inside a container. We leverage these same features for other side of the product. So then here you have services. These services are serverless functions as Knative understand them. So you can create a service either from YAML if you know Knative, or from an image if you know pre-existing images. We create catalogs, so you can choose one of the existing we provide. And then you have repositories. You can always link to your GitHub repository or Bitbucket or GitLab. And then if it has the expected format, we will create the functions and the containers for you. So we are mixing the services here with the actions menu down here. So what I wanted to show today is none of those, but this thing here that is called events. and this thing called bridges, which is very unique of us. So we just released our first beta version short ago, like last week. And there's still a lot of things to do, but at this moment, this is usable. So I'm going to talk a bit about what bridges are. So I've mentioned that when you have functions, you have many events, and you have to know who is producing an event, in which format, who is consuming it, and if you need some kind of transformation. So that's what we call bridges. We open source this repo last week. And in here, you can find some information about it. And you can also find some pre-configured bridges. Most of these are demos. You'll have to customize them to make them useful. But we hope, we did this for the first release. We hope to have lots of them, a lot more complex bridges. So bridges are connecting sources to targets. There are no rules in there, so you can connect anything as long as they have a clear type and they have someone understanding the source and someone understanding the target. I'll use an example for that in this demo. I don't know how familiar people are with Knative. I'll try to assume you are not familiar, and so I don't fall much into the line there. So if I press here, create a bridge, it will tell me, hey, you can create one from scratch, or maybe you can use this GitHub we have here. I can show you what this one does. This is a very simple one. This is going to configure a source that understands GitHub. Then there's a broker. A broker is like a channel. It's a place where you put your events, but it has some filtering capabilities. And then some other objects can listen from this channel, and they can listen in a pubs app, or there are different patterns that they could connect to this broker. Then there's a trigger. This trigger is going to communicate is showing interest in whatever comments in here. It can be filtered or it can be unfiltered, and it's going to connect this one with this event display. So what this is doing is just getting this GitHub source that is going to listen to push events, putting them, if you notice here, it is connecting to GitHub default broker. So it is pushing events to this broker. This broker is plain a standard broker. This is not persistent, but you have a range of options if you need persistence. And then the trigger, if you check the details, this is connecting to that broker and then sending whatever is in there to the event display service. So you can also add filters. So messages that come in here, they are cloud events, which is a CNCF standard where you can wrap anything that you send in JSON or binary format. And that's standard. Has at the standard you have at the headers some fields you can filter on without inspecting the interior of the message. And that's the kind of message that you expect from this source here to the target here. So I think that's for the theory. We can get our hands dirty at this moment. So if I create a new bridge, I'm going to disregard this here because some of the things we are doing are, we are providing a number of endpoints to connect to, like ranging from, I don't know, SendGrid, Slack. So we don't have all of them at the sources. We have some of them, but not all of them. So I'm going to get to the YAML. Jeff, I'm sorry, this is YAML again, YAMLism. So, and I'm going to base what I want to show in the Slack to Elastic. I'm going to do this Slack to Elastic demo. So if you see this repo, you have instruction on what you need to do. You are using, or we are using here, a source, which is Slack, and we are going to get messages from Slack and put them in Elasticsearch. So to do that, we have this bridge. And then I think you notice here, we have also two secrets. I'll get to them now. First of all, let me explain what a bridge is. So for you that know Kubernetes, you see that this is a standard Kubernetes object. We have at the spec only this array of components. So these components say that we have an exclusive channel for us that is going to be a broker, and it's called Slack. This name is arbitrary. So then there's a source. We want this source to be there. But since this is a Slack, we need a token to connect to, and we are going to set that in a secret at Kubernetes. So again, these objects, we created this Slack source. Some of them are open source, some of them are not. We will be open sourcing some of our stuff in the future. So this one is the Slack. It needs a token, and it is also saying that it is going to send all the messages to this broker called Slack, which is the one you can see over here. So then we also have a target. A target is the other endpoint of the event system. It can be one or many, like there are no rules in there. You can build your own graph. So with the Elastic target, we have the need to specify the endpoint here. And we also need a password or maybe a cloud token if you're using Elastic in the cloud, and also an index name. If you can perfectly replace this one with Google Sheets, for example, or Kafka Confluent. We built targets for all of them, and you can send the events anywhere. So this is the next thing, is that we are reusing those events, transforming them to wherever the system, the format it is expecting, and there you go, you're integrated. But you can, of course, build your own. All of these are functions and containers. And then finally, there's a trigger. This trigger is connecting the channel, the broker Slack channel, and is sending the data to Elastic Target. We could add here filters if we don't want all of the messages at that channel to reach to Elasticsearch. So I'm going to use this YAML, but as we said, we need to customize this. So I'll get back here to the documentation. Let's begin with Slack. So you have here that this is how you create a bot at Slack. We are using the real-time API. There's a new one. This is simpler, but at the same time, it has a bunch of less features. So we will come up with a new version for the event API at the Slack. But for now, let's create a bot here. So make sure that this is the URL. Like we say that here at the documentation, and we can say this demo1 and Triggermesh. This is our Slack channel I'm using for that. I hope my colleagues don't get puzzled when they see this coming. So I'm going to create the application. Here, we need to say this is, well, you can say whatever you want, but we need a bot. So I'll use a bot, a legacy bot, and call it for simplicity also demo1. And there we go. Now we only need to install the application to the namespace, to the workspace, sorry. So this is, we're expecting here the bot token. So I'm going to copy this. And I'll get back to the platform. I mentioned at the very beginning, I talk about secrets. So let's create this secret. This is going to be a generic secret. It is going to be Slack and token. I'm going to paste it here. So we have this Slack secret, which I think, if I'm not wrong, yeah, this is looking for, you see here, for a secret called Slack and a key called token. So that should be good. So we are done with Slack for now. So let's get to Elastic. I have this instance of the Elastic Cloud. This is a trial, but you could use the Elastic Cloud on Kubernetes, whatever. It should work with any of them. So let's see at the documentation again. So for Elasticsearch, what we need here is the URL. Then if I'm not using the cloud, probably I'm using a self-sign certificate, so we can use the skip verify or put our own CI cert, but it's not needed in this case. In this case, I only need either the API key or the username and password. So I'm choosing this other one. I don't even know how to recover that, but I copied the password before this meeting. So I'm going to get here, create a new secret. I don't remember the name of the secret, so let me check which name it is. Elastic and password. So I'm going to get here, create a secret, call it Elastic, and then the key is going to be called password. And I'm going to get to another place I had it here. So yeah, that's the password. So I have both secrets ready now. I'll copy this bridge. I'm created here. There's something missing yet. One of them is you can choose the index here. So let's say demo, and that's all. And then the address where Elastic is listening to, the Elasticsearch cluster. So I'm going to copy the endpoint and put it here. Okay, so I think this is ready to go. I'm going to submit the bridge. So this bridge is composed of this source, then the broker, then the trigger, then the target. Some of them are red at this moment. They're now, I could refresh, they are now green. Let's see, the trigger is also green. So if you click here, or if you see the YAML, you see that we have 4 objects and they are all ready. Sorry, status true. We are looking for that. So we aggregate all the status of those items and then show it, show the ready sign here. So this is looking good. Let's get to, I'm going to change the sharing. I need to activate the Slack and I'm going to show it. So give me a second. Okay, it took a while to start, so sorry for that. Let me look for the window. Here it is. Okay, so if I look for applications, I should find demo 1. Here it is. There it is. And this green thing here, it means that it is connected. So the source we have here, one of the objects we have at our cluster is connected. Let's see what happens at Kibana. Like Elasticsearch is connected to Kibana. So I'm going to launch Kibana. We are supposed to have a source responding to here. So if I write, hello, how are you? It should be sending messages to Elasticsearch. So I think for the sake of this demo, I want to show at the same time both screens. So I'm sorry for this. I'm going to I hope this is not too small. I'll increase the size of the web page. Okay, so this is Kibana there. And I hope you can also see, although very small, but you can see here Slack. So let's get to see if I can use this that small. I need to get to the indices to make sure that something arrives. So at the index, I have this one demo. This is new, and it seems that like the messages I'm sending in here are getting to Elastic. That's good. So let me create an index pattern. Oh, I need to create it here. There we go. So here we have the messages. I hope you can see this. Hello, how are you? In its own order, because I'm not sending a timestamp, but we made a connection with almost no effort. But let's build something with this. So just to make this slightly useful, not useful, not totally useful, but slightly. So let's create a tag cloud. So if we have all those messages getting in here, we can probably create a tag bucket. We are going to get the terms that we receive. We only have one text field. That's something we can, if we connect to, for example, Salesforce, we could get a number of fields here, and we could play with this a lot better. But let's say we want this, we want the top 20 to show there. Let's just update, and there you go. We have something more or less nice for a 10 seconds visualization. Oh, sorry, I need to save this. So let's save as a demo. And now let's get back to, let's get to a dashboard. We can add an existing visualization. We'll put this one in there. And I think we are ready to see this. We can save it. Demo. We are going to also tell it to refresh every 5 seconds, for example. Okay, so there it is. We have this cloud there, and I can say, hi, everybody doing good. Yes, 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 no, no. And you see here at the right how people not doing good are increasing live till they conquer the screen on the right. Okay, so this is just an example of what we can do. We are going to connect all the most important applications, and also you can bring your own. Like this is, we are based on standards, so that means that if you want to drop your own source or target, or ask us to build one, or you want to do transformations to connect one target to a different one, you can do that with us. We are building that product, and we are very actively looking forward people feedback or whatever you think that the product can serve you. And I think this is all I wanted to show you. I hope you like this, and if you have questions for me, I'm more than happy to answer.
Yes, actually, thank you very much, Pablo. Just wanted to know what are the types of integration are possible with Triggermesh, please?
Okay, at this moment, we have a number of sources, but there's some open source sources. So the Knative project has like a GitHub, Kafka, NATS, have a number of them. The API events is also one of them. There's some other repositories by private companies that they're open sourcing them, and we open source and it's hosted by the Knative community, the GitLab one. We also have AWS, Azure. We have the Azure Hub and also the storage blob. And the queue, we also have Google, Firestorm, PubSub, and a number of them. And then as targets, we sing Slack, and no, we sing Slack as source, but we also have it at target. We had Confluent, Kafka, SendGrid, Google Sheets, Twilio, all AWS service, not all, most AWS services, Tecton, so you can consider Tecton one target, and many more of them. And we are working on the connections on them, because you don't always get the one-to-one. You can't just plug everything. Our business is not plugging everything, and that works. There's some transformation in the way.
Thank you very much.
Great. Any questions from the chat? I was wondering, the way the events are managed, is that a specific format? Is that something native? Is it a standard? And how do you manage the flow underneath all these actions?
Oh, that's the big question. That's the pretty big question. So, cloud events is a standard. You can go to CNCF to check that standard, but that standard is just a wrapper. So that wrapper is just telling you a type of event, the source of the event. For example, one type can be GitHub pushes, but then it can be from many repos. So you say, hey, the source is this one, this report, that other, but there's so many other things you might be interested in. So all of the stuff you think it's interesting to filter should be an extended attribute in that shell that is the cloud event. But then the internal, that's tricky because there's no standard. So it depends on who you are talking to. Salesforce probably have strong standards, like you are expecting a message in one format. But some other, like Elastic, there's no standard there. They just ingest, you create the index mapping. That's pretty open. So what happens, for example, with Slack? A message can come, has a text, but then there's also media. It can be a thread. It can come from a user, can come from a bot, can be from a DM, can be from a group. So there's no agreement at this moment. So it is like if you are the first one developing a source or a target, you are to define that. And we are working on a registry where you say, hey, this is my message. The format is JSON, Avro, whatever. And here is the schema. So with that schema, you know the format, but there's no global standard. Like if you bring a new Slack integration with us and it says it's the same as you have, but with a different format, we'll ask you, okay, there's a standard way of saying which format is it? Like you have JSON schema. So we will need to put that JSON schema in our registry, and then everyone consuming it will say, hey, this is how we need to transform things. So there's no standard right now unless the source or target is strongly typed.
So you're trying to build a standard in the community?
No, we are not trying to build a standard. We are coming up with formatting that works. But if someone says, hey, this is not totally right for me because you're sending me the user, I'm interested in the channel, not the user, we'll say, okay, we can modify that real version, the type, and that's what you find in here. But you can find different versions of the schemas. If a company says, hey, there were no standard for this, but now there is, we'll adopt that. It's just like real life. It's whatever works for you. We'll provide some out of the box, And we hope that that works for most people, but that won't always be the case.
Great, thanks.
Thanks to you.
We will just leave a couple seconds to know if any other questions are popping up in this chat. And afterward, we will follow with a 5-minute break to give a rest to everybody and to know if anyone needs a drink as well. So after, during the break, I will share on the chat of YouTube a little bit the code of Slido to answer to the following question and to make the audience participate. Thank you very much. So we are back after this 5-minute break. So if we look at the results a little bit from the survey, so which cloud native topics would you like to see in the future? So we'll leave a couple minutes to people. Apparently, there is only one answer here for rootless containers. I got a couple of other questions here for Rancher Lab, Argo CD, and Terraform. If anybody has other session that they would like to see in the future, please don't hesitate to share it with us to make it more interactive as we do this cloud native Romandie for the group, the open source community, and to make sure that we answer to your needs and to your question, and we look holistically 360 degrees around us.
So rootless containers, if I remember, was a subject we had at the first meeting with Philippe Burissa, who presented Podman, if I remember properly.
Very true. So we still have the Rancher Labs, Argo CD, and Terraform suggestion. Kubernetes, GitOps. So we'll leave 1 more minute, and then we will leave the floor to our colleague Eric Sorenson from Puppet presenting us Relay, the innovative solution.
Great, I think these are good subjects, and don't hesitate to contact us as well if you would like to speak at one of our next events.
I think, Eric, the floor is yours. So if you want, you can take it from there.
All right. Let me share this. Let's see if this is. Oh, Lord. I should have tried this before. It says that I have to quit and rejoin Zoom in order for it to share the screen. Hold on. I'll be right back.
No worries. We are a couple minutes early, so probably you can go grab a drink quickly and then to come back for the third topic.
And if there's questions or suggestions in the chat, we can talk about that in the meanwhile. Don't hesitate to comment on it.
Also, that leaves us a little bit time to add a couple more topics if anyone wants to participate as well as a speaker or to present a kind of a tech talk with us at Cloud Native Romandie. Please don't hesitate to reach out to us either today or afterward to the Cloud Native group that we have on Meetup.
There we go.
So our colleague Eric just joined.
All right. Let's see if this works now.
We can maybe stop TD screen so you don't have to steal it. Great, perfect.
There we go. Does that come up and is visible? Or is readable?
Perfect, yes.
That looks good to me. Yeah.
Great. All right. So I'll dive in. My name's Eric. I am probably connecting from the farthest away, further away from me than Zurich is. I'm in Portland, Oregon. I've been at Puppet for about 8 years, and I previous to that was a systems administrator, SRE, DevOps person, and I've been doing large-scale configuration management for a really long time. I used to work on CF Engine as an open source in the open source community before Puppet existed, and that's where I met Luke and got involved with Puppet, the Puppet project once it matured enough. At Puppet, I'm a technical product manager, and outside of work, I like to play music and play pinball. So I want to talk today about Relay, which is, it's really interesting to hear the Triggermesh talk because there's a lot of similar concepts to what we're doing in Relay in Triggermesh. It's also an event-driven system, and some of the same kinds of integrations that Pablo was talking about are available also in Relay. So it'll be interesting to contrast and compare the two different solutions and see where things are where there's some similar lines of thought. And the reason why we started Relay is because at Puppet we found that there's this shift in the center of gravity from how automation happens and where it happens. And this, a lot of times you see this being said as, oh, we're moving to the cloud. But I think that the cloud is more of a instrument of change or a catalyst for change than it is the way that the change happens. So you could adopt cloud-centric practices, but still use them inside the data center, for example. But some of those changes are things like we're moving from this idea of task-driven automation or classic Puppet style state enforcement into a more event-driven world. Everything is run kind of at a greater arm's distance via APIs rather than making changes on systems directly. And there's a smaller part of your time is spent doing configuration management. It's a smaller part of the stack, which for Puppet is a very interesting thing because we want to continue to have a future and have a company and help solve people's problems. But certainly that when there are things like a container that is immutable, and that when there's a change to it, you build a new container and deploy it, you're not making changes live onto the state of that running system. In fact, that's a complete anti-pattern in this world. And so we had to sort of rethink how we wanted to address automation in this world. So about a year ago, we started this project called Nebula. And the idea behind Nebula was that it would be a service that you could use for continuous deployment for your applications and infrastructure if you were in an organization that had kind of this organizational model that you see at the top of the screen on the right, where there was sort of a DevOps team or an application services team that was responsible for managing the infrastructure that the applications were deployed onto, and then a group of application development teams that would be constantly spinning up new applications. And historically, or what we saw when we talked to customers is that those app dev teams were frequently able to come up with their own solutions, and then those DevOps teams were often kind of trailing behind in cleaning up after them or trying to provide some standardization and governance across a very wide spread of existing and mostly working but but pretty much unmanaged application deployment strategies from those different development teams. And so we thought that that would be a good entry into this, and there's certainly a lot of activity in Cloud Native CD. And one of the topics that was just mentioned was Argo CD, which is really similar, has a very similar approach here. In parallel with, so as we were building this, we got into a beta phase with this. And also similar to Triggermesh, we use Tecton pipelines underneath the hood of the service that we built for this. It's a really awesome Cloud Native CD that came out of the Knative build project. And we got involved with that as community members and as part of the Continuous Delivery Foundation. And that's been really great. It's really been, has a ton of powerful capabilities, and the amount of activity and development around Tecton has been really awesome to be a part of and to contribute in the ways that we've been able to do that. Tecton's neat too, because in a very Puppet kind of way, it will build a directed acyclic graph of the different tasks that make up a pipeline and run them in order by figuring out what the dependencies are between them. And it's a really powerful technology. So in parallel with that, we started working on a project called Lyra, which was an open source project that was about cloud native resource creation and provisioning. And we got some early prototypes out, started talking to people at KubeCon in Barcelona last year. And it turned out that people were pretty happy with the existing solutions that they had with Pulumi and with Terraform. And so we sort of shifted that into this idea of doing cloud native resource orchestration, that maybe we could link up those provisioning pieces to things that were outside of the provisioning step. So for example, you could receive a ticket, provision infrastructure, and then send notification after the infrastructure was created through integration with Slack or ChatOps or other types of external services. And because there was an advantage to being able to connect to things that were outside of Terraform's understanding and its purview, and there were lots of Kubernetes specific tools, but it was sometimes hard to get people to get the tools to work in contexts that were outside of Kubernetes themselves. So to tie together, for example, the Kubernetes part of your deployment with the database, which might be provisioned on RDS rather than live inside the cluster. So those kinds of things were things we thought we could help out with, which really led to this idea of workflow automation and building a workflow that was sort of could have a step-by-step description of what those steps would be and would help you traverse it, which ended up looking very much like what we had built with Nebula. And so what we decided to do with Lyra was to take it and combine forces with that Nebula project to start contributing more upstream to Tecton and to the other CDF projects and to integrate it. And there's been a few really interesting developments around the technology that we built as part of Lyra. You could still see it on GitHub at the Lyra Proj for Lyra project namespace. And like, for example, there was a Hira implementation in Go. If you're familiar with Hira for storing data in Puppet, we did a completely ground up rewrite of that in Go, so it would be easy to integrate with other Go ecosystem tools. And just started getting a lot of interesting pull requests and contributions onto that project. Just recently, somebody added a Terraform integration, so you can use Hira data store as a data source for your Terraform data. And that's been kind of an interesting part of that project, is just to see like what have we built there that was interesting technology that we can integrate with other tools in the space in an open source ecosystem way. But all of that is sort of recent history, and the question is, what did we learn from doing all that? The first thing is for that continuous delivery, particularly cloud native continuous delivery, is really hard. This is a landscape from James Bowman's site, and I found that even though it's a couple of years old, it still has, for example, the old Puppet logo on it. That things are getting very complicated. There's a ton of tools in this space, and there's a ton of tools that bring these, that are sort of all either need to work with one another or they want to take the place of one another. And so it'd be we found it would be tough for us from Nebula's standpoint to either take over from a feature. It wasn't our main focus as a company. And so to try to catch up with some of the companies that were 100% focused on that, or tools like Spinnaker that had several years of many developers working on them, was not going to work out super well for us. And from a customer standpoint, people either already had something that was working okay, or the idea of going to a pure cloud native CD play was like really far away for them. It was really hard for them to think about that from where they were at as an organization. One other thing that came up was that events are everywhere. Events are really important. There's even just that set of tools that's in use in one organization is pretty complicated, and they all both generate and consume events. As Pablo was just talking about with Triggermesh, Slack, for example, can both be a place that sources events into the system from interacting with a bot, as well as something that where you want to receive events that come out of other systems so that people can stay notified on Slack channels when other things happen across the infrastructure. And there's lots of tools that are in that same situation. When we looked at what DevOps teams were working on, there might be 10 or 20 of those kinds of workflows that were all in play that are tying together events from these different sources and receivers. That was really interesting. And the last sort of lesson that we took from that was that there's this thing of a DevOps dumping ground, as we call it. And this is my favorite animated GIF of all time, a giant tire fire stretching off into the distance. And a lot of times, this is where organizations end up, or where teams end up when they try to build their own tools. They might use Lambda functions for managing EC2 instances, and then they have this whole bunch of Lambda functions that the operations team maintains. I talked to a team that has just scheduled jobs that run out of cron to clean up EVS volumes that are unused, or they have reused one of those CD tools for operations style workflows like cost management, user and resource cleanup, those kinds of things, which is inefficient because there's a lot of reinventing of wheels. It can be expensive because teams are sort of recreating those things each time they need them. And it can be risky because a lot of times those dumping ground kind of tools circumvent or don't pay attention to security standards, and so because people are just trying to get a job done, and so they can present a security risk to the organization by exposing keys or doing other kinds of unsafe things. So all of those things were what led us to start thinking about Relay, and it's what we call a system of intelligence that makes sense of the signals and events that come in from upstream, and then orchestrate downstream services based on simple workflows that you pull together from existing a library of content or things that you modify or write yourself. And I'll talk a little bit more about what that looks like. This is a screenshot from the service. It runs as a software as a service, and there's kind of this taxonomy of different steps that make up the components of the service. There are trigger steps that come in that are based on those upstream events that come in. In this screenshot example on the right, there's 2 potential trigger steps that could cause this workflow to be kicked off. One of them is a manual trigger where somebody goes in either through the API or through the command line interface that we have, or through the web interface directly and runs it. Or there are various other kinds of triggers like schedule based or webhook based or push event based. Those triggers run action steps, which are the things that actually get work done. Each action step is a container that runs in Tecton. We've reused a lot of the Nebula infrastructure and the platform that we built for that, and added some of the more event-driven capability, and added a wider library of content and use cases that people can get done with it. But the action steps are just a simple container that runs, sort of does one thing, and then exits and passes the output or the data transformation or the outcome of having run onto the rest of the workflow. And those can be run in serial, they can have dependencies between them, or we'll parallelize them if there's not an explicit dependency, so they can run faster. And then down towards the bottom, there's a query step, which is like a, we want to, if you need to wait for an external event to happen, like another system to finish running, or a manual approval, or those kinds of things, that could be a query step that breaks out of the workflow and will continue on once the condition has been met. Going a little bit deeper, like in the Triggermesh example, and I think like everything, we have this idea of it's not quite workflow as code or infrastructure as code, it's workflow as YAML. So it's almost code, but not quite. The YAML is a pretty simple dialect. It's not, I guess by contrast with Triggermesh, you're not writing a complete CRD. We have a higher level dialect of YAML that we then generate and submit CRDs from. So the language is a little more compact and a little more, it can be a lot briefer than having to have a whole bunch of Kubernetes specific code in there. But it is specific to the relay system. It's not reusable across other tools. So that might be a trade-off there. The YAML has a few top-level keys like a description. There are parameters which need to be fed in order for the workflow to run. And this is how you can present things to the user interface or to external APIs to say, hey, look, I need a value for these, or I need you to override the default, and this is the default I will use if one's not provided. We also have the concept of a secret store. You can see that on line 23 here, where there's a HashiCorp Vault service that's running inside of our GKE cluster and is running as part of the relay service that has a trust relationship between the APIs and Vault, but not out to users for reading secrets. So once you write something in there, the workflows can see it, but you can never extract the unencrypted secret. You can only delete it or overwrite it with a new one. And you access them with these YAML custom tags that are like a exclamation point or a bang secret, and then the secret name. And we also have the idea of these output tags, and you can see this down on the bottom line, which is highlighted in line 38, where a previous step has produced output that's stored in a metadata service that we run that allows for steps to pass state and pass information between one another as they flow down as the workflow goes through. I'll get into more detail in this. I'm going to do a quick demo, and we'll talk through this a little bit more. But that's just kind of a very quick whirlwind view. You can see in this one just this. So this is the text representation of the previous step that I showed in the GUI, and so a lot of the visualizations that we present are extracted from the information that you provide in the YAML, and you can sort of flip back and forth between those, which I'll show you in a minute. Another important part of this is the integrations. Again, similar to Triggermesh, there's a wide variety of things that people want to be able to do with the system, and it's fine to have a workflow engine, but if you can't connect it up to the types of event emitters and the types of actions that you want to run, it's not really very useful. And so we're both building as well as trying to integrate with and help foster an ecosystem, an open source ecosystem around the most useful integrations. And the integrations can do various, again, like that, back to that Slack example, an integration can contain both workflow examples, it can contain event receivers, that is triggers, and it can also contain action and query steps so that you can use that same service to get work done as well as respond to events that come in from it. If you have existing containers, as I mentioned, the containers that are run as part of relay workflows are just stored in a registry somewhere, or as long as the service can reach that registry, pull down the container and execute it, and extract output from it when it's done running. Obviously, you probably wouldn't want like an Nginx service or something like that to run, because it needs to terminate so that the next step in the workflow can go on. But any general purpose container can be used. And it's also easy to take a Docker file that you have that builds a general purpose container and then layer on the the relay specific tooling, the SDKs, and a small command line tool that we have that runs inside of the container in order to access that metadata service that I mentioned a minute ago, so that you can access secrets and pass data around and those kinds of things. You can just install that with a command in the Docker file, or add on a layer from our container build step that includes that tooling for you. I'm gonna flip over to a demo. Let me see if I can make this work here. Did it change? Yeah, it looks like it's still highlighted, so I assume that's still sharing. So this is the Relay web interface. I'll just go through this because it's easier to demo than going through the command line interface. But we do have a pretty rich command line interface that I'm pretty happy with how it's come out. And the idea is that you should be able to do everything you can do from the GUI through the command line, and in fact, probably more, because it's kind of a text-oriented experience particularly if you're authoring and developing things. I'll walk through this one example that's a real-world example in the spirit of eating our own dog food. I wrote this workflow to update our homebrew repository for the Relay CLI. Whenever there's a new release that's triggered or that comes in from GitHub, it will trigger this workflow and send a pull request into our homebrew repository, so that the new release will be reflected in the brew tab. And so here's a kind of a running example of that workflow YAML that I was talking about earlier. We have two parameters that get passed in and extracted from the release information, a tag and a SHA, so that the homebrew can get updated correctly. And the steps here, there are really just two of them. There's one that does a clone of the brew repository and creates the pull request. This accesses that secret storage service I mentioned a moment ago, and then uses the parameters from the execution of the workflow. And the actual script that it runs, it got too complicated to have inline. If it's just a few steps, you can use it as a YAML mount that's directly inline shell script that's directly in line in the YAML. This one got a little bit too complicated, and so I have it sort of self-hosting, and it pulls down the script and then uses that as the input to the Nebula container. There's still like some of the serial numbers have not yet been filed off and changed from Nebula to Relay, and I still refer to it in that sometimes. So sorry about that. That's if you see anything that says Nebula, like even the app URL at this point, since we're still in beta, hasn't changed over, just think mentally it is the same thing as Relay. So that runs, sends in a pull request, and then sends a Slack notification when it's done. And in the sidebar over here, you can see that this is where the secrets are stored. And as I mentioned, you can change them and delete them, but you can't read the value of them as you'd expect. When I look at the preview, click over in the preview code, this is a live version of that screenshot that I showed that has the directed acyclic graph that shows the order in which the steps will be run. Shows what they need and what information they need in order to run secrets and parameters. And when I look at the history of the run, we can go through and see the last time that it ran. We store the output and the logs from each step so that you can go back and have an audit trail. And see the exact output from each of those steps. So if something goes wrong, you can see what happened. In this case, we were able to successfully send in the create the pull request and send it in, and the Slack output did not the Slack step did not generate any output. So that's sort of a world. Let's see. I think that's about all. That's sort of a whirlwind tour of the UI. Some other interesting things that we have set up. Here's the documentation site that I've been pretty heavily working on myself, and we have also a this account's logged in as a non-admin user, but we have the idea of access control that's pretty simple role-based access control that allows people to either only view output, to be able to run steps that already exist. We have an approver roles if you have one of those steps that requires manual approval that I was talking about earlier, and then an administrator role that allows you to do everything to create new workflows and add new users and those kinds of things on the service. So each one of those is additive, so it's not like you have to have a combination of roles. It's just each one provides all the powers of the previous role plus some new access. And that's pretty much that's pretty much all I wanted to show. I could kick off a sample workflow too if that would be helpful. You can just see that it'll run. Here's the message that we want to put. Oh. Hi. Camptocamp. Run that. And so the service runs in GKE, as I mentioned. It will, as under the hood, what it's doing is it's provisioning and it's generating Tecton custom resource description, and then submitting that into the cluster, generating a pipeline for it, and then it'll execute the pipeline on GKE. This one is queued for a while, but hopefully it will kick off in a moment. I guess while that's running, if there's any questions, I'd be happy to answer them. And hopefully the demo gods smile on me and this will finish before too long.
Thanks, Eric.
Sure.
I have some questions for you.
Great. Yeah, go for it.
This is coming from Puppet, and I think in Lyra there were some functionalities to choose the language you wanted to use. So is it planned to support something else than YAML? Maybe some kind of Puppet DSL like the other tools coming from Puppet?
It's possible, yeah. That's definitely a question that we get a lot. We wanted to start off with YAML just because it's kind of the lowest common denominator of configuration, cloud native config tools at this point. If we can add Puppet language support in a clean way, I think that would be beneficial for people. But the thing that we ran into with Lyra was that there were we had to make enough changes to the Puppet language in order to get it to go, that or to get it to work in this new context, that it wasn't exactly like people that already knew Puppet had to change what they knew in order for it to work. And people that didn't know it still had to learn a lot in order to be successful with it. And so that's why we kind of stuck with just YAML to get started with. I do expect over time we'll add more sophisticated language support, but I kind of want to see if we get far enough with if you can do enough with this to find out what the edges are before we start adding in a whole new DSL.
Okay.
I also had a question, Eric, for you. Can it connect to on-prem services in my data center, please?
Right now, these Relay only talks to APIs and it'll receive events. So if if the thing that you're working on inside your data center can send events to the outside world, then we can act on those. as far as reaching back into the data center in order to run steps or to run containers on your own infrastructure, we have a plan for that. As you might imagine, it's a really common feature request. We're not gonna, we want to continue to host the service ourselves and not have like a fully on-prem version of this, but we also, we will probably move to something like a delegate or a proxy kind of model where there is a small piece that you can run inside of your data center that will connect out to the service, but allow you to get to do things like send pull requests back into an internal GitHub Enterprise installation, for example. So that is definitely something that we're planning on building. Right now, it's only things that are publicly accessible.
That's really interesting. I'm seeing several things here. This big similarity, obviously, between Triggermesh and Relay is it's all based on events and passing data to, from one process to the other. But it's also very different because it looks like Relay is more oriented towards some kind of continuous deployment. You have a product at Puppet as well when it comes to continuous integration, which is Puppet Pipeline. So where does that get into the equation as well with Relay?
Well, so a couple of things there. Puppet Pipelines, we sunset that product and are not using that anymore. We definitely took a lot of the lessons that we learned from pipelines and brought that into Relay, as well as into the continuous delivery product that for Puppet itself, for CD for PE, or the continuous delivery for Puppet Enterprise. That's kind of the provides pre-built pipelines for promoting your Puppet code through different environments. I would say that Relay is a little bit different than that in the sense that you could use it for continuous deployment, but we really expect, like if you look at the different use cases and the integrations that we have up on the site, they really are more DevOps focused than they are about application deployment. Obviously, they're going to be able to tie into app deployments and to app development teams, but we expect that the main users are going to be SRE DevOps folks that have more like use cases that are around like the things I was talking about earlier, like cleaning out empty load balancers, I was talking to a user the other day that has a sandbox environment in EC2 where the developers can spin up any resources they want to, but they can't exist for more than a week. And so they wanted to know if anybody has had these had instances running in the sandbox for 2 weeks, and if so, to send them a Slack or a Microsoft Teams notification, and potentially also to kill the instances if they were really stale. So those are the kinds of use cases that we're really targeting with Relay.
Great. So a bit more like maybe GitLab CI pipelines, but with events that can trigger the pipelines and logic that is pre-built, so you have a higher level language.
Yeah, exactly.
Pretty cool. So
that run did eventually succeed, fortunately. So there's the output of it, and GK is running really slow today, but oh yeah, there we go. The message was hi Camptocamp. So
cool.
And yeah, any other questions? I'm happy to keep chatting. Well, we're also on, I guess, I didn't show the final slide, but we're on, if you want to talk about it more, we have a Slack instance at slack.puppet.com, and we're in the Pound Relay channel there.
Thank you. Thierry,
Thank you so much, so Eric, for this presentation. So far, I don't see any more questions in the chat. So we are 5 minutes late. Actually, we are exactly on time at 6:50 tonight. I wanted to thank you and to let you know as well for the next meetups that we already have planned. So it's scheduled in 5 months from now, in 4 months from now, sorry, September 24th, and 6 months from now, November 26th. So one will be in Geneva and the other one will be in Lausanne. And then we will see, depending on how unfold the current, let's say, COVID situation, to follow up as well on doing more meetups virtually. Like this, we can invite people, that allow us to invite people from different places, like Eric from Oregon and Pablo from Sevilla, Spain. If you have any other question, please don't hesitate. We are here to answer. And otherwise, you can put on the chat in the Cloud Native Romandie Meetup group. And we would be very happy if you can share with us a little bit what did you prefer the most about this evening. So you can join the last question at slido.com and just let us know what did you prefer, if you prefer virtual, if you prefer physical on-site meetups, and as well the presentators, the topics, anything you'd like, you can drop us a line, and like this we will move from there. Thank you so much again for joining us this evening. And if you have any last question, please let us know.
Thank you. We hope to see you another time.